Hey, how's it going, everybody? It's Juan Galt, and I got a really interesting conversation for you guys today. This is a physics conversation that I had with David Robinson, Ryan Herbison, and Anthony, a new friend of ours that dropped by, and we've been having some really fantastic conversations. And a variety of them over time, and especially with Anthony, have been around physics, right? So this is a four people conversation. There's two podcasts. They're both about an hour each, or so each, and we touch all the big questions more or less in physics and have a really interesting mix of different kind of schools of thought around physics. Ryan is into electric universe theory. David Robinson is around the rational scientific method and thread theory, and I'm coming at it from philosophy. And then Anthony's also philosophy, but he has an interesting kind of electricity background and kind of a spiritual sort of take on it that makes it a very good dynamic conversation about a very important topic that is, I think, riddled with a lot of confusion and more or less bullshit. But you be the judge. I hope you enjoy it and let us know what you think. Peace.
All right, cool. So my name's Anthony, and I'm with some really smart motherfuckers right now. And we're here to talk physics, but I think that also crosses the line into philosophy. And so I was telling Juan, one of the things I think would be great for us to sort of is at first to talk about the things that we agree on. And I definitely I think we all agree that our current models of physics are they're wanting, to say the least. That we need to start reevaluating the way that we look at physics. There's a lot of opportunities. There's obviously everyone's heard of string theory, but there's also the rope hypothesis. There's also the electric universe, and many more concepts. So personally, for me, I'm going to say a lot of stuff that that's going to rely. It's going to be like sort of this contradiction. It's going to rely on like physical. It's going to rely on a lot of the things that physicists tell us, a lot of the studies that we've seen, and then I'm also going to say, yeah, but those studies are bullshit. So this is more something that I think, where it's basically, I think that I'm not really quite sure about a lot of things, even the very nature of reality sometimes. So that's basically my introduction.
Yeah, so I'm Juan, and Juan Galt. And my approach from about most things is sort of philosophy based, and one of the sort of essential kind of problems that I have with modern physics is basically that I don't trust the way in which the academic system works, and I don't trust the way that physics is funded today. I think that throughout history, you always get some sort of academic sort of cartels that kind of end up making a bunch of bullshit that's convenient to the powers that be, or maybe the powers that be pay off the smartest people to go talk about stupid shit that didn't distract them. So basically, the government subsidizes most of the academic system and then throws a bunch of money at a variety of sort of physics programs and sort of builds a bunch of things. So I think it's important to sort of approach the modern physics establishment with a certain amount of skepticism and perhaps even distrust, but at the least sort of don't take them obviously at kind of as legitimate, or perhaps even sort of fully just not take the word as authority. And I think we would anyways, but that would be one of the main kind of things that I kind of think about.
I'm Dave Robinson, so I'm coming from the school of thought called the rational scientific method, and using that method, I'm also interested in discussing what's called the rope hypothesis and thread theory. So the rational scientific method is a different competing version of the scientific method. It's not empiricism. It's basically based on assumptions, because the idea is that science, and in particular physics, is about explaining consummated events in reality, not about making predictions. So I think that the mainstream can make predictions. I think their math works out fine, but I think the mistake that they make is thinking that just because they can make predictions, that their assumptions, their physical interpretations, are automatically proven or correct, or any of those things. So I don't think that their assumptions are wrong. I think that they are irrational, and that's the problem. is that really in order to understand what it means to understand an explanation in physics is to be able to visualize the object so that you can visualize the mechanism behind it, and that's how you understand it. So I think it's crucial to define words like object and existence such that they can be used consistently, and to be able basically to visualize the mechanism. And it's not a matter of what you believe, it's not a matter of the truth, it's not a matter of empirical verification or disproving or knowledge or fact or any of those observer-dependent concepts. It's all about simply understanding a mechanism and communicating that mechanism clearly so everybody else can understand it. Whether you believe it is basically boils down to your personal opinion. But the entire method is around what are the requirements of rationality, what do we need in order for an explanation to objectively be qualified as rational so we can actually understand it.
Yeah.
I thought so. Whoever wants to.
I think the core is the four of us. If anybody has something wants to throw a question or something, if it's a really good question, we'll go for it.
Hi, I'm Ryan Herbison. I've just always been really interested in astronomy, and ever since I was a kid I remember reading tons and tons of books on astronomy and never really fully understanding the math on some of the higher level theoretical mumbo jumbo, and it turns out most of it's probably exactly that, just mumbo jumbo that doesn't really mean anything. And in recent years I've taken an interest in the electric universe theories and how it ties in with geology, and how plasma physics actually make a lot more sense than, well, scientists are always looking for all the missing energy in the universe, and well, it's right there in front of their face and they can't see it. 99% of the universe is plasma and it's electrical in nature, and I'm more and more convinced of that every day. Anyway, that's it for me.
Awesome. Yeah, so I want to kind of follow up on what you were saying about rational physics and what is rationality. One of the things that I see in modern quantum physics sort of, I guess, theory is that they've sort of departed from the Aristotelian logic sort of principles, which basically says that A is A, and A cannot be A and B at the same time. Or A cannot be A and B and maybe C sometimes, depending on what's going on, right? Like, you have to have a clear definition. And this is where I really sort of am online with where you're at, David, with you have to be able to visualize it. You know, there is sort of at least four dimensions that I recognize as sensible. There's a location, there's movement, right? There's so there's like there are 4 dimensions we can talk about, right? And usually the fourth one is time, right? So movement over distance, right? So maybe you can speak a little bit to that, and maybe we can talk a little bit about dimensions.
Yeah, you want to talk about dimensions?
Sure.
So the concept of having time of a dimension came with Einstein, and that's through what's called Minkowski space. It's this mathematical way that they construct relativity, special relativity, and general relativity. And so yeah, they have 3 dimensions of, quote, space, and then they tack on that 4th dimension of time. And the way they describe it is, well, if you're going to meet, your friend for coffee, you got to tell him where and you got to tell him when, and that's supposed to kind of make sense out of it. But what they end up doing is having time dilation, warping time, and length contraction, mass increase, all these other, what I would argue, are irrational concepts. But my main beef with the dimension thing is that they don't use their definitions consistently. They don't define their terms consistently. So if you define a dimension in a physical sense, what we're really talking about are 3 mutually perpendicular directions in which an object may face: length, width, and height. So you have directionality and mutual perpendicularity. Right? And if you think, well, there's no 4th mutually perpendicular direction to length, width, and height, and to say time all of a sudden is a dimension is inconsistent with your original definition. And it's just, you're now including a totally different concept and calling it the same thing, and physically it makes absolutely no sense, because time doesn't have direction.
Yeah.
So for me, the whole concept of dimensionality is actually pretty critical to the whole conversation that we're having. I see expressions of dimensional planes, and the critical one I'm going to bring up kind of time and again is the square root of -1. We can actually model, well, I'm kind of getting ahead of myself. So when we talk about the fourth dimension, mathematically it's an extremely useful way of, and you would probably say abstracting, using an abstraction of a fourth dimension, but it's extremely useful for predicting events and for demonstrating how past events came to, how they took place. And so from a certain perspective, I have to give a level of credibility to these dimensions. We'll get into the square root of -1, but maybe even more core is the concept of negative numbers, that we can model, like let's suppose we're trying to count apples. There's no such thing as a negative apple, but yet we have to use that abstraction merely to do simple arithmetic and resolve simple problems that we face. Getting further into abstraction is this concept of the square root of -1, which in our physical realm in which we inhabit, it doesn't even exist. It's technically a non-existent thing, but it's only non-existent in the terms in the way in which we have defined the square root. And this is actually, the square root of -1 is an extremely useful concept, just like fourth dimensionality. It's an extremely useful concept for modeling electrical systems. In fact, our entire AC power grid is built, I shouldn't say it's built upon the square root of -1, but the square root of -1 is integral into making the proper calculations so that we can get correct power loading. And it's not just electrical systems. Many of the systems that we use incorporate this concept. And so I would agree that we don't really have maybe the best definition of what dimensionality actually is. It's kind of like this generic term that we use to describe sort of these abstract concepts. And if we wanted to get like really deep into philosophy, we could say, well, even, up, down, left, right, backwards, forwards, our three spatial dimensions is just an abstraction, just an abstract concept. But that's probably getting a little bit like too off the deep end philosophically at the moment.
Yeah, I mean, we can talk about the sort of the way that philosophy approaches abstractions versus instances and specific sort of elements. And that's definitely like that's something that I can tackle in a very short amount of time. But I think, speaking of time, maybe I'd like to demystify the word time a little bit, because it's sort of one of those things that people think about as this kind of magical thing that nobody understands. But time to me it's a very simple concept, right? I think time is basically the measurement of movement of an object relative to another object, based on an arbitrary definition of time, an arbitrary clock, right? So there's kind of cycles in the human experience, like the sun goes around the earth or the moon goes around the earth. And so we chose to say, let's say the way in which the sun goes around the earth is one clock, and we count it as days, right? And so we can measure now the movement of one object relative to another based on sun time, right? And
so time is relative, is what you're saying?
Well, time is relative to the specific. It's an arbitrary measurement, right? So, but I mean, you could measure the movement of an asteroid that's going across Pluto with sun time or moon time around the Earth, right? And you would just need to be able to sort of keep ticks of the moon around the Earth here on Earth, and then sort of sync it to some sort of digital clock in Pluto. And it would be consistent. It would be a constant, right? A constant sort of arbitrary definition of time. And so time to me is it's a very much a human construct, and it's useful for our sort of particular sort of mortal ambitions, right? But it's not some sort of element in the world. Like if all humans die, time is dead as well, because there's nobody to perceive or think about it. It's simply, it's a human means of measurement.
So the speed of light seems like one of the critical measures that we use of time. And if we accept, and I don't know if we do accept it, but if we accept that the speed of light is a constant, regardless of the velocity of the source of the light, we end up kind of inescapably with this concept that time seems to do weird things. Now, I'm not really super down with everything Einstein said or did, especially maybe all the equations and general relativity, but I do hold a pretty significant amount of respect for the way that he viewed the relationship between light and time, because we taught you very correctly noted that time is relative to what to various physical objects, whether it's an electron around an atom or a quartz crystal vibrating or the Earth around the sun. The reason that the speed of light is one of these like kind of crazy concepts is because it seems to be the same regardless of wherever we are, whether we're approaching the source or leaving it. And the only way to resolve that sort of, I don't want to call it a problem, but that anomaly, the only really way to resolve that is for time itself to start doing crazy things. In other words, being relative to the observer. In other words, if the speed of light doesn't change, then time itself and how fast it's occurring has to change.
I'm not sure I get that. Do you want to take it? Yeah, go for it.
So just to try to gloss over some of the things and address that. I think earlier briefly you said something about they can make predictions with higher dimensions, and that kind of gives some something to the idea, like there must be something to it. And I think that's kind of what I mentioned when I opened up, was it's kind of what they do is they're able to make predictions, and then they turn around and assume that their assumptions are somehow there's evidence for them or that they're correct, even though their predictions are mathematical and observer based and they work, but they have nothing to do directly with reality, because you can't define reality in an equation. So the rational scientific method, well, if they're not defining their terms consistently and we can't visualize the explanation, then it just doesn't explain anything.
Yeah, so a useful metaphor, for example, might be tribal sort of pre-scientific sort of cultures would think, oh, well, there's a god called, Tepoztlan, let's just say, or some other god that, shines, comes and brings life and then dies every morning, right? At night it dies and comes back, and they would be accurate in that this god does this thing in a persistent basis. They don't understand the mechanisms by which the sun moves around the earth or the earth moves around the sun, but they would have a capacity to predict the consistency.
Exactly. It's like the falling apple. I can use Newtonian mechanics to okay, I'm going to drop the apple, let it fall for 3 seconds. I can predict how fast it's going to be going after 3 seconds. But that's totally different than explaining what physically happens in reality that actually draws the apple towards the earth. So they're just two different disciplines, but what they've done in empiricism is mash them together and get them all confused. And that's how you end up with this reification, where they're treating empirically based, observer based concepts as if they somehow exist in reality. Forces exist.
Can you elaborate on that? Because I'm not really understanding the distinction between, if I can model exactly how the apple is going to fall, and let's say we shoot an apple into orbit, right? If we can model exactly like how it's going to flow, where it's going to go, we can make extremely precise predictions based on at least a certain level of understanding. We might not understand why does gravity as a force act continuously and always, but nonetheless we can still model what is occurring, and so it does reflect reality to me to a certain extent, although it might not be like a completely the most common denominator of explanation. So could you just elaborate a little bit?
Yeah, absolutely. So when I say reality, I'm talking about, you define reality. The way I would define reality or existence is objects, which an object is that with shape, objects having location, so it's qualitative, right? Shape is qualitative, it's not quantitative. So when you start talking about mathematics, every single equation in physics, every single variable represents a measurement, right? It's a quantitative measurement, something you can measure empirically. Every single one of those variables works that way. So it necessitates an empirical observer, right? So what they're really just talking about are processes of measurement. So yes, they're using pattern recognition, measurement-based pattern recognition. They're discovering patterns, and they do persist, but it's just pattern recognition versus pattern explanation. So in the apple example, I would need, because I think you might have said a force briefly there, and that's really an example of what I'm talking about. They see the apple fall, and this whole aggregate of observations with respect to gravity, they'll come up with a term like force. And of course, force is something you can measure. So it's completely empirical. It's on the evidence side of things, on the observer side of things. And then they'll convert that and treat it as if it's something that exists in reality. Like the force caused the apple to fall, as if it's somehow acting on the apple. That's irrational, because force is the word that you gave what you observed. Right? It's not actually something that exists in reality and is acting on the apple.
So I would actually go the exact opposite of what you just said and say that you don't even know that an apple exists, because the only way that you can measure that apple is through the mediation of the force that's occurring from it. In fact, it's kind of like where we say, you know, I'm not touching you, I'm not touching you, right? Because technically I'm not. It's just a force acting between us, and there's still space between there. So I would contend the exact opposite, that everything you said, that it's only objects, and there is no energy, it's just an abstraction. I would say there's only energy. There in fact are no objects. Objects are just an abstraction.
Okay, well, the point with the mathematics that I was going into there for a second, that everything is observer-based. Existence is an observer-independent concept. Whether or not something exists doesn't depend on observers. So something has shape and location regardless, and the point is that those definitions can be used consistently. So you mentioned knowledge, or how do we know the apple's there? We don't know. That's why I'm taking belief, truth, proof, knowledge, and fact, and throwing them completely in the trash can and saying we have no choice but to even be able to attempt to interpret the empirical side of things. We have no choice but to make assumptions, which is a statement you just temporarily take at face value. You don't believe it. You're not saying it's true. You're saying, let us suppose that these such and such objects exist, hypothetically. And let us suppose that they behave like this. That's one possible explanation for such and such. So I'm not saying I believe it. The whole rational scientific method is simply about communicating the mechanism so that we can understand it. Once understanding is established, whatever you do after that is no longer part of science. Whether you believe, whether you want to verify, whether you want to do whatever, simply about understanding the mechanism. So.
Yeah, so you, just real quick, when you have hold the mic pointed towards your mouth.
Oh.
Yeah, just hold it like this.
How's that?
Yeah, just like I'm doing right now.
Okay, gotcha.
Yeah, so just captures it like a cone. Yeah, so you touched a little bit on the paradox of, you know, how do we know that we exist, right? It's kind of a fundamental philosophical question, and I mean, there's a lot of people that have sort of talked about this, but I mean, my basic position on that is the Descartes sort of answer to it, which is, I think, therefore I am. Maybe we're a brain in a bat, maybe we're in some sort of matrix, right? But the fact that I am thinking about and wondering whether I exist or not is proof that I exist. That's a fundamental sort of piece of epistemology, or how to know. Since we know for a fact that we exist because we're thinking about existence, then from there we can build, okay, well, I exist, therefore things can exist. There can be things in this sort of universe, this realm, and therefore now we can start talking about the things that exist. And with that, we can say, okay, so how do I know whether what I'm looking at exists or not, right? And at that point, we start talking about, okay, what are the mechanisms by which we can experience or sense or sort of measure or touch that which is in our environment? And at that point, sort of we start getting into things like science. That's one element, and the other one just becomes is just pure abstract, like logically consistent or internally consistent sort of methods of visualizing mechanisms, which is very much what you talk about, David, is about the visualization of mechanisms, and mechanisms that are logically consistent can exist, but don't necessarily exist in the real world. So that would be sort of my answer to that question.
Well, you were talking about the speed of light, and I'm not so curious. I mean, I'm curious about the speed of light in different situations and what it could be, and whether outside of the solar system it might operate at a different speed. But one of the things I've learned from the Electric Universe guys is what more important question is, what is the speed of gravity? Because a lot of the guys that have done modeling of the solar system and the way the planets orbit tend to indicate that gravity is instantaneous instead of traveling. But you talk to most scientists today, they will tell you that gravity has a speed, and gravity is limited by the speed of light. And that doesn't make sense, because when you start doing the actual math and the actual calculations, it means that every object orbiting another object is actually off-center to that location. Like the Earth is 8 minutes behind where the Sun is, so therefore you'll get oscillations in the orbits, and the entire thing would break down on a computer model very quickly. So gravity must be instantaneous. And I don't know, thought I'd throw that out there.
That's such a great point, because what they're saying, this came with Einstein. So after special relativity in 1905, he wanted to explain, quote unquote explain, he wanted to incorporate Newtonian gravity into special relativity, which became general relativity. And in order to do that, he had to assign a time factor to gravity, because nothing can travel faster than the speed of light in special relativity. So gravity can't, quote, travel faster than the speed of light. Newton's equation, his law of gravitation, doesn't have any time factor, and it implies that gravity acts, it's not even instantaneous. It's there is no time delay. And if you think in terms of the rope hypothesis and thread theory, which supposes that every atom in the universe is connected to every other by a rope, and that all of those ropes are under a little bit of tension, then you have a mechanism. The rope is the only mechanism that I can think of where you have basically instantaneous action at a distance, or it's not really even instantaneous. That tension is already there. So the sun is bound by gazillions and gazillions of ropes to the earth, and that gravity is, that tension is, there's no time delay. Nothing has to travel. So there's nothing traveling faster than the speed of light, because there's nothing traveling. The rope's already there. They're already under tension. So when the earth moves relative to the sun, the angles on the ropes change, and that's what accounts for the inverse square regime of Newton's law of gravitation.
Where do these, how is it that two objects, say two protons separated apparently spatially, are connected, and through which medium? Through a dimension?
Through an actual physical rope. So a hydrogen atom under the rope hypothesis is a convergence of ropes from every other atom in the entire universe. It's like a koosh ball.
It's kind of like there's only one proton, there's only one electron.
Well, there's gazillions of atoms, but one atom is a convergence of ropes from every other atom. So if you imagine just gazillions of ropes coming in from all angles, that converges, and finally you have that one atom. But all atoms in the universe are like that. They're all interconnected to one another.
So what you're saying is that these atoms are all connected through the three-dimensional spatial reality that we inhabit. It's just that, so can we see those ropes? How can we, or we can only observe their effects?
Right, we can only observe their effects. You can't see the ropes because they're also what are responsible for light, whereas gravity is the tension, the aggregate tension on the ropes binding two objects. Light is the torsion or twisting in situ. So that's actually your eyes, your retinas are connected to every single atom in this room, and those atoms are pumping, and that torques the ropes, like if you twist a clothesline. And that's, light is the motion of the rope. It's not even a thing. It's just the twisting in situ of the rope, and that's what, quote, transmits light.
So I really like, I actually, even though I don't fully agree with you in certain respects about physicality, I really do like the concepts that you've laid out just now about how every proton is connected to every other proton, every photon is connected to every other photon. I'm not sure if I could personally verify that they're connected three-dimensionally. I kind of think they're connected through probably a series of infinite dimensions, but that's more speculation than anything. But even though it's kind of a separate theory hypothesis than what kind of my own personal physics that I'm lately following, I actually, from what you said, in a lot of ways, it's, in other words, one proton can't exist without every other proton being connected to it. That without the other protons, it makes no sense. And so from a certain perspective, I say, well, then that kind of means there's only one proton. I mean, of course there's individuation, and there are many protons, but in a certain way, there's kind of only like one thing. There's only one proton, because not a single proton can exist without all the other ones being connected as well.
Well, yeah, that's so I wouldn't, like you said, it's not one proton, but underlying the entire rope hypothesis configuration, if you could untangle all the ropes and untangle all the atoms, so a hydrogen atom is both the proton and the electron shell. So when each rope converges on an atom, a rope is actually two threads twisted around each other like DNA without the rungs in the middle, two strands twisted around each other. When each of these ropes approaches an atom, one of those threads breaks off and wraps around and the other one penetrates to the center. So you have gazillions of ropes wrapping around the atom, or excuse me, gazillions of threads wrapping around a single atom. Gazillions, so it's like a ball of yarn, and you have gazillions of threads penetrating to the center, and that's what forms the proton. So the proton is like a dandelion or a sea urchin, and the electron is actually a ball of yarn, a pulsating ball of yarn. And so to go back to your point about the single object, in the rope hypothesis, there is only one object. If you could untangle everything and pull it all apart, what you would end up with is one single closed loop of thread. That's it. And and it never actually ends up that way because these formations are permanent, but that's what weaves the entire rope hypothesis configuration is one object, which is a little poetic because it's like we are actually literally part of one cosmic whole.
And I do like how that aligns with certain kind of past, I don't want to say religious, but concepts from Buddhism, Hinduism, and even Christianity if you really try to stay away from the dogma. But I kind of want to try and reveal what maybe argue that there's some contradiction from what you said previously about there are only objects exist. And maybe I don't want to put words in your mouth, but as I understand, basically energy is an abstraction. Energy doesn't actually exist. Time isn't even really in existence. Only objects exist. So that's I have that. Okay. But then now you're saying there are these ropes connecting objects to other objects, but you can't actually see the ropes. You're not actually able to. You're not actually able to directly measure these ropes. All you're able to measure is their effect. So you're kind of having to infer their existence, even though you can't actually see them. So it seems somewhat contradictory to what you talked about earlier about only objects exist, only what we can actually observe and see exists.
Throw a bone in there. Yeah. So I mean, my position on that is that if the universe is a rope hypothesis sort of universe where it's one rope in a highly complex sort of kind of wovenness of yarns essentially, right? Then our capacity to measure these ropes is only limited by our technology and our capacity to actually observe the smallest sort of elements of existence. But that's the limitation is a human technological limitation. It's not really a kind of physics or limitation, right? Like it is only, we didn't really know about microbes or amoebas or stuff like tiny organisms until maybe 400 or 500 years ago or something like that, until somebody came up with a microscope and they were like, holy shit, there's a whole universe down there, right? And perhaps one day we'll have the technology to be able to see these ropes and measure them and sort of start actually kind of, building chart patterns and sort of, around them type things.
It is impossible to see the ropes. We'll never see the ropes. When you think about it, because you said observation. So when I say existence is that which shape and location, it's an a priori assumption. It's not based on any empirical verification. The only objectively distinguishing characteristic is that it can be used consistently in a scientific dissertation. So whether or not we can see it has nothing to do with whether it exists. We're just saying, let us suppose this exists. But this actually applies to any physics. It doesn't matter. You don't have to be doing the rational scientific method. When they're, say, doing the Large Hadron Collider and saying they're finding quarks, that's actually an assumption they're making. They have the evidence. They have the data coming out of the detector. They're looking at the data, and they're saying, oh, well, this is quarks because da-da-da-da-da. But they're saying, we're assuming that this is quarks. They won't phrase it that way, but that's what they're doing. They're assuming that quarks exist in order to explain the empirical evidence.
It seems like such a ludicrous thing to say. So you've taken these atoms, and you've put them at nearly the speed of light, an enormous amount of energy, especially relative to their actual dimensional size. You've smashed them together and observed a certain, basically, electromagnetic spectrum coming from them. And you're saying, oh, yeah, we know what particles are in there. You've completely destroyed what that object is. And now you think you know what the particles are when what you're measuring is the massive energetic component of the result of a ridiculously large explosion.
Yeah, because I know
My only comment is it's like they're taking mechanical clocks and firing them at incredibly high speeds and they're looking at the tiny little fragments of the gears breaking off for the 100 millionth of a second that they exist before, I don't know, they vaporize or something, or they just disappear from the scope. And yeah, they're making that argument that, yeah, we found something. Let's just smash things faster and see if we find anything else.
That's such a brilliant analogy. I'm stealing that from now on.
Yeah, and so going back with the empiricism point, I mean, look what they're doing. Every single empirical means of investigation that you can possibly imagine, right? Whether it's a process of measurement, whether it's an experiment, whether we're talking about our sensory organs, we're always talking about an object, or at least one object that's interacting with its environment. Your eye interacts with its environment. The sensors in your skin interact with their environment. The Large Hadron Collider detector interacts with its environment. Your radar gun interacts with its environment. All measuring devices, sensory organs, detection instruments, they all interact with their environment. And what that means is we're necessarily talking about some kind of interaction that's happening out there. We don't know what that interaction is. We don't know how the magnetometer interacts with the magnet. So because all of our empirical means of investigation are external to, the neural activity that mediates consciousness or whatever, they're all external, they're all self-contained. We have no choice but to make an assumption about what it is that actually exists out there with this measuring device or detector, how it's interacting with its environment, what's actually happening in order to explain the nature of that empirical interaction that we get back. And that's why we have no choice but to make assumptions.
Yeah, so what I hear you saying is that we cannot know for certain how things behave when we are not looking at them. And when we look at them, the act of observing is inevitably going to have some effect on the behavior of the thing we're observing. And so now we have to kind of make certain assumptions about what would happen if we weren't interacting with the environment through observation. Yeah.
This is going to sound a bit like a rabbit trail, but I think it's really integral to when we talk about objects and observing objects. So we've already kind of covered that we can only actually observe objects through some kind of, we call it a force. It's sort of an assumption for sure. But what is an object? Like, have we even really defined object? And I really like to think about objects in terms of singularity, whether we're talking about a proton or a human or an apple. And this term singularity kind of like evokes thoughts of black holes and Albert Einstein, but I really mean something much more basic. And really it's a very philosophic concept. It's something which is at a level which can't be divided without, that can't be observed without necessarily destroying its boundary function. So whether it's a proton that we've smashed together in the Large Hadron Collider and destroyed its boundary function, or whether it's trying to get inside the brain of a person, without penetrating that boundary function and interfering with it in such a way that you can't actually reliably know that your observations are what would have been happening if you hadn't disturbed it. It's sort of, when I say singularity, it's kind of like an event horizon, and this does relate back to black holes, but it's a very to me, it's kind of trippy in terms, and it goes to a very basic philosophic level of how does anything exist at all? Like, where does the universe start, and how did it end, or is there no end, there's no beginning? And so I like to think in these terms of event horizon, and I don't really ascribe to the Big Bang, but let's just this is where we're going to take some of these ideas of physics and just sort of play with them a little bit. So we have this Big Bang, it happened. Can we ever travel beyond the edge of that Big Bang? No, we can't ever travel beyond the universe if we assume that the speed of light and all these things, and I know it's a lot of assumptions, but the edge of the outside of the universe, that sort of outside of the sphere, is an event horizon that we can't cross. Our universe is contained within this event horizon. That's sort of an outer event horizon. But even so, even with that, there's still inner event horizons. We talk about smashing protons together. There is an event horizon around the proton. It's a singularity. It's a singular object. It's a singular thing. And merely by penetrating that event horizon, you've basically disturbed what was originally going on inside it. And I'm not sure if that's made a whole lot of sense, but this concept of singularity to me is a very key and fundamental aspect of defining what is an object in the first place.
So all I want to say was to follow up on your point earlier about, when we observe something, we affect it. What I'm saying is that take your eye, right? Your retinal cells are specifically tuned to filter out. There's tons of interaction happening between your retina and the environment, right? There's heat, the atoms are moving around, there's gravitation, there's all sorts of stuff. But that eye or that retina is in a specific way that it actually filters only for light interaction and also only for visible light interaction. That very narrow band of visible light within the entire electromagnetic spectrum, we only see, I think it's between 350 and 700 nanometers. Yeah, right. Right. Oh, okay.
Yeah, the visible light spectrum is so narrow. It's less than 1% of the entire electromagnetic spectrum, and that's all we can perceive. So, the universe in itself, we don't even know. Like humans, as a species, like we see 1% of all that there is, and we see a little bit more when we use other detection means. But we still see such a minute amount of the actual universe. It's just mind-blowing. Who knows what's out there?
Yeah, so exactly. And then that applies to every single, it doesn't matter what, we don't have to talk about the eye. It could be any sort of empirical investigation mode. You actually can't get a naked picture of reality as it is. It's impossible. Every means that we have to gather something about reality is through empiricism. It involves surface-to-surface contact, whether it's your eye, whether it's any other sensory organ, whether it's a detection instrument. We're getting a highly filtered interaction. The interaction, say, takes place here. Something interacts with its environment, there's surface-to-surface contact, da-da-da-da-da, and then it filters out the vast majority of what's happening there, translates it into different kinds of motion, like maybe your eye translates it into electrochemical motion in the optic nerve, and then that goes into your visual cortex and neurons. So the physical context changes completely, the motion changes completely, it gets filtered. So no matter what, you can't get reality as it is. There's no possible empirical means to do it.
So what you're saying is you're basically observing an effect of an effect of an effect of an effect before you can even hope to make some kind of observation.
Yeah, and you're just getting clues at best. You're just getting clues, which is why we have to make assumptions about, okay, let's assume this is how this interaction actually happened in reality.
And then the whole thing is being filtered and processed by the brain or the software program or whatever to output the results so that we perceive reality the way it is. And that's somehow built into ourselves as animals, as creatures on the planet. I'm pretty sure that most creatures see it quite similarly to us, but it's still that question.
Yeah, I mean, I don't know that I can that I can quite yet get behind the idea that it's impossible to have certainty or reasonable certainty about what's happening in the world through empirical observation. I think that the question of whether it is possible to get certainty or reasonable certainty about the behavior of matter through empirical observation, to me, is a methodological question. Like it depends on how you're attempting to measure it, and there may be ways in which perhaps if you throw a Molotov cocktail sort of anarchist style and then you see just light, right? I mean, the light is going everywhere, and we happen to be able to capture it, and we could capture it from all kinds of different angles, but the explosion happened before the light hit our eyeballs, right? And so yes, we're experiencing an effect of a behavior, and that's the information we have to work with, but in that example, the observation didn't necessarily influence the way in which the explosion happened. So it seems to me it's a methodological question more than it is a sort of philosophical kind of axiom.
I'm going to disagree with you. The very last thing you said, that it's methodological and that philosophy is not so much related. I'm going to say, and I'm going to try and broaden our scope a little bit. Right now we're talking about the observation of external events, and earlier you brought up some really good points about I think therefore I am, and so one of the first things we can establish is, okay, there is something, right? And I might not even say I think therefore I am. I might just say that I am. Like, it's pretty clear that there is experience happening. I have a certain cognitive ability to recognize that and sort of self-reflect. But I think we come to a very critical juncture here in our type of knowledge, and this is what philosophy is what it bothers with thinking about. That's a poor way of phrasing that, but it's how can we have knowledge? What kinds of knowledge can we have? What kinds of reliability can we have? And so here I'd like to separate internal from external knowledge. We've been talking about, okay, an explosion happens, we observe an effect, the light hits our retina, and it processes through our brain, and all these things happen, effective and effective and effect. And so what we're doing now is we're questioning how much can we rely on any of the things that we're observing in the external world? And it seems like, I feel like we have a certain level of agreement here. It's probably not 100%. Maybe it's 99.999%, but it's not 100%. We can't be completely certain of it because we've recognized this sort of chain of effects that happen. On the other hand, I like to consider the concept, and the most basic one is that on the inside, internally, I can be certain of at least one thing for sure, and that is I am. That there is an experience, there is an existence. And that sounds really basic. Well, duh, yeah, of course things are happening. But the separation here is that's internal knowledge. You don't need necessarily the external world to be able to validate that something is happening. Even if you were, Helen Keller, you still have thoughts, and you still have, maybe you have sensory input, maybe you don't. Let's just suppose for a moment you're pure consciousness and there is no external input. You can still create and construct all kinds of realities within the internal part of our own consciousness. And we could probably make some leaps and jumps here and start talking about spirituality and consciousness and how, everything is consciousness. And can we, the observer, if the observer isn't conscious, if a tree shit in the woods, does a bear care about it? Or some ridiculous way of phrasing that. But the main point is that internally, I think that we can be 100% certain of certain kinds of knowledge, not the least of which is that I am and consciousness exists. But externally, everything has a certain level of associated doubt that maybe it doesn't. With everything that happens that we perceive externally has a level of uncertainty, whereas at least some things internally we can be 100% certain of.
Yeah, so this goes back to the question we touched on earlier about abstractions versus instances within reality, and this kind of philosophical question. And David, you and I had a conversation about that a long time ago, and I think that I don't know if you still kind of agree with me on that, but basically the only environment in which perfect objects, like two perfect objects or two objects that are perfectly equal to each other can exist is within the mind. The brain is kind of this magical thing, this amazing kind of thing that can simulate images and sort of auditory and sort of sensory kind of data in perfect ways. We can imagine an apple and we can imagine two apples, and those apples can be perfectly equal to each other in our imagination. But in the empirical world, in the world where apples actually exist and we can eat it, no apple is perfectly equal to another. And so when we're actually using something like 1 + 1 apple equals 2 apples, when we're actually trying to apply math to sort of instances of an object, we have to sort of account for a certain amount of error, and we have to have definitions that are abstract and are reasonably accurate relative to the specific object. So we can have 2 apples, and we can say, okay, 1 apple plus another apple equals 2 apples, but if we weigh them, 1 apple might weigh a little bit more than the other, and so we just kind of, we accept that sort of margin of error.
Yeah, so on the certainty point you made earlier, you talked about the explosion. So, of course, we still have to see the explosion. It gets filtered through your eye. It gets filtered through your retina. Maybe you feel the heat, and it's filtered through your sensory organs. Maybe we measure the light with some kind of device, and it's filtered through that device. So it's always filtered no matter what, and we're dealing with an interaction externally of some kind that gets filtered through this interaction and translated. And so at best what we get is clues. So I do think that the clues are wonderful and very, very, very helpful in trying to determine, to brainstorm a hypothesis about what it is that exists in order to explain. Because ultimately what we're trying to do is explain the empirical evidence. We want to explain why the apple falls, explain how the explosion worked, and explain and so on and so forth. So in terms of certainty, I don't think, the problem there is how do you define consistently knowledge or certainty or any of these terms, because ultimately it always depends upon an empirical observer who is verifying or measuring or something to that effect. And so there's no way to really concretely and consistently define certainty. And how do we certain? Because ultimately, it is all empirical, and all we can do is make assumptions. And on the math point, with the equations, it's the exact same thing, because every single one of those variables, doesn't matter what we're talking about, velocity, doesn't matter if we're talking about charge, doesn't matter about voltage, whatever it is, or even if it's dimensionless, like it's spin, quantum spin, or a coefficient of friction, no matter what it is, those are quantitative measurements. Because they're quantitative measurements, they necessarily invoke an observer who is doing the measuring. And by observer, I mean just the tool or the instrument you're using to measure, not necessarily the person's head or whatever, their mind. And so because of that, no matter what, you cannot remove the observer using mathematics. So no matter how much investigation you do, there's always an empirical observer. It's just another clue. So I'd say, to round that off, in an empirical sense, what is the empirical? The empirical, or the evidence side, are your observations, your measurements, your equations, your experiments, all of these things that entail empirical interaction of some kind. And on the other side, you have theory, which is just your assumptions about what exists, about how things are spatially oriented with respect to one another, about their behavior, and then you use the theory as a proposed or possible explanation to account for the and you can also make a decision, I think this is the one that best explains, but it ultimately boils down to your opinion, your scientific opinion.
Yeah, so you're talking about a couple of things there. One of them is, what is the purpose of science, or what is the purpose of means of acquiring knowledge? And that is a very much a human and mortal sort of arbitrary sort of thing. Like, people have different purposes for acquiring knowledge, and the accuracy of those methods will be dependent on the degree of on what you want to achieve, right? You don't necessarily need a microscope to determine certain things, but depending on what you want to do. I think that when we talk about math, for example, I think that it is possible to have perfect certainty within concepts, within sort of the imaginary sort of world, the simulation machine that we have in our heads. If we define one as an object, right? Like, one equals a thing. Let's say an apple, and then we say, okay, we're gonna say that plus or addition is the process, or the sort of the process of saying we have one object and we have another object, and so one object plus another object equals this new number called 2, and so 2 is an abstraction that equals one and another one, right? And so that methodology, that sort of system that we just defined, is perfectly consistent within the imaginary world, in our brains, within the human experience. How accurate that is relative to the empirical sensory data that we have, because we have, in a sense, 6 senses, maybe even 7, right? We have vision, audio, taste, smell, kinesthetic, and then, I mean, that's basically it, right? Maybe you people say, like, the amygdala is another sort of sense. Okay, maybe there's something there. But then the other element, the other sense that we have, is our imagination, this sort of capacity to simulate and imagine sort of systems and images and objects and mechanisms. And that sense is a realm where perfection can exist. And where certainty can exist. So philosophy is a system of thought that can acquire certainty. The problem is, does this perfect theory, this like, you can have systems that are internally consistent and perfectly defined, and things sort of make sense within the whatever definitions you have, but when then you try to apply them to actual sort of context or like empirical evidence, and they don't match. And science is the process of testing theories which should be internally consistent, and testing whether those theories actually explain the empirical evidence that we can gather. And wherever evidence counters our theory, science says, okay, the theory must be wrong, the theory must subject itself, or human scientists should subject theories to evidence. Where evidence contradicts your theory is wrong, not the facts that are wrong, right?
So if I understand what you're saying correctly, then we use kind of our internal, and I'm going to phrase this kind of in